welcome again to yet another interesting video. This is a problem on Leetcode and it is a hard complexity problem. The problem description is that trapping rainwater given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. And there are a couple of examples as usual on Leetcode. I will explain the problem with this example. It's a smaller array which we can go over quickly in comparison to the other example. And let me bring up Excel spreadsheet to talk about it. It would be easy to do it on Excel spreadsheet. So, and let me just unfill so that I can fill it and walk you through as I fill it. So so what are we doing? So we have 420325 as the array, and you have to represent, think of it as like some sort of bar per element. And now once you have this picturized, you have to think about it as a container in which you can fill in water, and 0 is like base of the container. So you will have, and you can't have a slanting container because the rainwater will go out. So you need a container which has the top is parallel to the bottom. So now in this type of structure, whatever the unfilled boxes are, that's the size of rainwater that you can store for this particular problem, and this example. So that means we will store 2 units of water here, 4 units of water here, and then 1 here and 2 here, which will become 9, and that's the answer for this particular example. So let's fill it with water, blue color water. So that's it. So the response here is 9, as I mentioned, 2 plus 4 plus 1 plus 2. Now if we have to think about a solution programmatically, how to find the unit of rainwater that a given array can store, the brute force approach is that we could iterate through each element, and for each of the elements we will try to find two values. One would be left max, left max and right max. So left max would be the leftmost maximum element, and right would be the rightmost maximum element. And let's talk it with one example. So for example, if we are here where the value is 2, we will try to find the left max of 2, which is 4, and right max of 2 is 5. So once we have found that, we would do a min between the left max and right max, and in this case that min is 4, and then we would minus the element value at that particular index on the outer array. So it will be 4 minus 2 is equal to 2, and then in this case it will be 4 minus 0, 4, and the left max for 3 is 4, right max is 5. So again the min between left max and right max is 4, and 4 minus 3 is 1. So we'll have 1 added to the a result variable or whatever you want to call it. And then for this element the left max is 4, right max is 5. So we are doing 4 minus 2 is equal to 2, and sum of these is 9. When the outer array is at the start or at the end, it is essentially a no op. There isn't anything that will get added to the answer, because the max like for example, if the the outer loop is at this place, the left max and right max will both be 5, and there won't be anything that will get added to the answer here. So that's the intuition for brute force solution, and in this case we are talking about like two loops. One is the outer loop, and then there are two loops inside of it. One is trying to find left max, another is trying to go, looking at right max. So essentially it is n by n into n. So O n square. There isn't any space that we are adding, so space is constant here. Now let's go ahead and write that program, because that is the exciting part, right? So what are we doing? So we're gonna add answer. We are going to take left max and right max. We obviously need our favorite loop variables I and j, and then we are going to iterate from start to end. And then we are going to initialize left max is equal to 0, right max is equal to 0. As I walk through that example, for every iteration we have to reset these values, because we want to find left max and right max according to the element that we are going to execute in the loop. And then we needed two loops. So one has to go back from I to 0 to find the left max. Left max is equal to math dot min left max and height of j. So that is my loop for finding the left max, and then I have to find the right max. Alrighty, and then we have, I have to find math.max, right max, height of j. And once we have found the left max and right max of the particular element, all we got to do is that we got to add the minimum of those and subtracting the value of that particular index, and that index is the outer loop index. So I think all looks good. Now we got to return answer. Just want to make sure that okay, this looks perfect. Let's see what test case we have. So we have the test case that is mentioned here, and now we're gonna run it. Fantastic. So the answer matches. Let's run another test case, the one that we looked at an Excel spreadsheet. So this one also goes fine. Now let's try submitting it. So like I mentioned, the time complexity is O n square. There isn't any space that we are adding here. There are a bunch of variables, etc., which is considered as constant space. So it is O n square. Let's see, if Leetcode has some examples which are like super long arrays, we could see this solution landing in timeout for that type of example, and the submission might not go successfully. But let's try and see what happens. So time limit exceeded, that's what happened, and that happened for a very long array. I don't know how many elements are there, but clearly for something like this, the time complexity would be in the order of O n square, and that is why such a test case is failing. Now we will look at other options to solve this problem in linear time and then try and submit it, I think that will tell us that why it is important to look at other options which are less time consuming. So that is what we're going to do next. Okay, so now we want to solve this problem with linear time complexity so that we can submit this problem, and also we do not want to respond back in any interview with something which is not efficient. How to do it? So, one intuitive thing that we could do to reduce time complexity by looking at the program that we created earlier is that in the brute force option, all what we are doing is that we are finding left max for a particular element and then right max and then finding min and subtracting the value at that particular index. So we could easily reduce the time complexity if we can store left max in some array outside of this loop, and similarly a right max outside of this loop, and then we have another loop which compares the left max and right max of a particular index value, and then just keep on adding answers. So instead of the nested loops, we would have three loops which are not nested. That means the time complexity will be linear for the program. We would although pay on the space side, because to store left max and right max we would need some arrays. So the space complexity of that program would be on versus o1 in the brute force example. But it is good to look at that option, and then in the last we will go to a solution option which is linear time complexity, and there is no space involved in that. Okay, so in this one, as I mentioned, we gotta make two arrays, and we will have two arrays of height length, and this is left max, this is right max, and then we need a variable for our loops. We need a variable to store the result. So first loop, so we are starting from 1, height dot length I plus plus, and before we start we will have to have left max 0 as height 0, because we want to compare the first element with 0 and then so on and so forth. So that's what our loop for 4. Okay, so let's just go inside and populate left max I. This is going to be the math.max of left max I minus 1 height of I. So now what are we doing here? So going back to the example that we had which we discussed earlier. So supposedly we are at the first index, which is I is equal to 1. So all what we are doing is that left max of I 1 is max of the previous element and the current element. So in this case, left max of 1 would be 4, and as we move along, like the next one, so when I is 2, so we are comparing the left max of I minus 1, which is 4, with 0. So again the left max would be 4. So this loop would make sure that left max is populated correctly. Now we need to construct a loop for right max. So similarly, in the last element of right max, what do we want to do? We want to store the last element of our input array. So, and then we would start a loop from the second last element, which would be height dot length minus 2, and I is greater than 0, I minus minus, and then all what we're doing is right max of I is equal to math dot max right max j plus 1, because we're comparing the second last element with the last element, and j is the second last, like not the j. We only have one variable. We want to be smart with our storage requirements. So now height I. So this loop will populate the right max array. Now we have both left max and right max. So now what we have to do, okay, now we need another loop where what we are doing, we are starting, essentially we need this loop only. So let me just copy paste it. So alrighty. So in this loop, what are we doing? So we are going to do answer plus math dot min of left max I and right max I, and then we are minusing the height I. So essentially, whatever we had in the nested loop by the ways of storing left max and right max, which is called as dynamic programming, we are now getting rid of those nested loops and reducing the time complexity from n squared to n. So we are all set. So now we have return answer. So all looks good. Let's try and run few test cases. Perfect. So why don't we try with this one? So this also goes well. Now let's submit it. Our previous submission failed, time limit exceeded. This one goes fine. Runtime is 3 millisecond, memory is 49.1. So fantastic. So we improved our solution a lot by making very small changes. Okay, now next we will look at a solution which improves the solution further, because in this one we are taking up a hit on space. So if your space is a limitation for a constraint supposedly asked to you in any interview or so, then this solution will not solve that purpose. So let's now look at the most optimized solution. Ready? So if we have to improve this solution further, and the only thing which is bothering is the space complexity that we have added with this one, which is O(n), do we really need to store left max or right max? If we look deeper, we probably don't have to. What we could do is that we could have a two-pointer approach where we are comparing the value at left pointer with right pointer. In this case, 4 with 5. If 4 is less than equal to 5, then we are comparing 4 with an initial value of left max, which would be a minimum value. So 4 is greater than left max, so new left max would be 4. And then we would move the pointer to the next element. So next element is 2. So 2 is again less than 5. We are going to compare whether 2 is greater than left max. It is not. So now we know that we have some opportunity to increase or add value to our answer. And how much we would add? We would add left max minus the value at that particular index, which is 2. So 4 minus 2, so we'll add 2, and then we will keep going. So now 0 is less than 5. Yes, we will look at what is the left max. Left max is again 4, and the value at this element is less than left max, so we're going to increase our answer by how much? 4 minus 0. So our answer becomes 6 up until that point. Then we're comparing 3 with 5. So when 3 is also less than 5, we again look at whether 3 is greater than left max or not. It is not. So we'll add to the answer, and how much? We will add 4 minus 3, 1. So it will be the answer will become 4 plus 2 plus 1. So that is 7 at that point in time. Then we are looking at 2. So 2 is less than 5. Again, the left max, 2 is less than left max. So 4 minus 2, 2, and 7 plus 2, 9. So that's what it will be. Now we are comparing the height with the height at left index with right. What if that the condition where the value at left is not less than equal to 5? Then what we are doing is that we are going to compare whether the again we are looking at calculating the right max there. So what we will do is that we will compare the value at that element with a hypothetical, in the beginning, a hypothetical right max min value, and if the value, and obviously in this case it will be bigger because we will set right max to the integer min value. So right max would become the element value at that index for the first iteration. And then with the same logic, we will keep comparing if the element value at right index, whether that is greater than equal to right max or not. If it is not, then that means now there is an opportunity for us to add some more value into the answer field. So let's go ahead and write that solution. When we write it, things will be more clear. So let me first clean it up. Alrighty. So what are we doing? So we need 2 pointers. So one is left. Oops, not so good with spellings. No, it is just typing issue. My spellings are all right. Okay. Height length minus 1. And then what we need our favorite answer is equal to 0. We need left max, and the initial value that we want to set is a minimum value. Yeah, okay. Min value, and then we also need a right max. And then we are doing a 2-pointer loop where we want to break if left is less than right. When that happens, we have crossed the midpoint, so there is no point going forward. And then we are doing the height of left, whether it is equal to less than equal to height right. If it is, and we also need an else block. If height left is less than equal to height right, what we want to do, we want to compare whether height left is greater than equal to left max. We need another else block. So if this is greater than left max, then that means our left max should change. Left max would be height of left. If the height of left is not greater than left max, then that means that the previous left max is bigger than height left, and we have an opportunity to increase our answer by how much we will have by left max minus height left. So this is where, like, when we are at 2 compared with 5, 2 is less than 5, we come to this particular condition. We're looking at whether 2 is greater than 4. 2 is not greater than 4, so answer would become 4 minus 2. That will be added to the answer. Now for the other side, like, if you have element which is not following this condition, supposedly we had 5 here and we had 4 here, then we want to look at from the back of the array, which is from here. And for that, again the same thing, it's just that we're going to look at the right index, and we're going to look at right max, and instead of left incrementing the left pointer, we would be decrementing the right pointer there. 6 height, right, this is equal to right max, height right. So if the right index has the bigger value than right max, then we want to set right max as height of right. Oops. Okay. And if the height right is not greater than right max, then we know that now what we should do, we should subtract right max height right from right max and add it to the answer. And what we're doing right minus minus. So that's what it is. I think to understand this particular part, how this will get invoked, we'll have to imagine, like, if 5 is here, so what we are doing, so we are comparing left with right. 5 is not less than equal to 4. We come here, then what we are doing, so we are comparing the height right, which is 4 in that case, whether 4 is greater than equal to right max or not. It is greater than that. We have set right max is equal to 4, and then we go next. We are looking at 2, whether the right will come here, and then we are comparing 5 with 2. So 5 is not less than equal to 2, so we come here, and then we check whether 2 is greater than equal to right max, which is 4. It is not, so it is going to add answer with 4 minus 2. So same thing that I mentioned in the order that we have this one. So I hope it is clear. I know it is a little bit difficult, and that is why the problem is hard, but I think by going through all type of options, I hope that the solution is clear. And then we are going to return answer. So that's pretty much all we have to do here. Let's run our test case. Fantastic. I'll run another one. And let me switch. So everything goes fine. So clearly this one, we don't have any need for additional space. The time complexity is ON. So, and in many cases it will be less than that as well, if we have, like, an array in which left and right are both decrementing one after the other. So, but in worst case, it will be ON. So let's just submit it. Fantastic. So the time complexity is as I mentioned, it is on and it shows up in the runtime, which is reduced. Although this might just be a function of how test cases are written, because the time complexity otherwise also was on, but still it was like in the previous one we had three for loops. So going in more deeper, it would have been like 3 into on, and that is why this solution is faster. All right, yeah, I think I loved looking at this problem. I hope you found the video helpful. Let me know if you have any questions for me. Thank you.